In this video, we are going to look at the examples in the 19-2 slides. We're starting with this one. Find angle A to the nearest tenth of a degree if A is 7 and C is 21. Since we know we've got this triangle, here is angle A, this side is 7 and this side is 21. We've got opposite over adjacent is 7 over 21. So that's sine, or opposite over hypotenuse. Sine of A equals 7 over 21, which is 1/3. Now, we can take the inverse sine of 1/3. I'm going to bring up Desmos, which is a great calculator website. Just a second here, sorry, should have had this prepped before. Okay. I can share Desmos. Go. And I'll just do sine to the -1, sine to the -1 of third gives us 19.5 degrees. Just make sure that this is, yes, this is in degrees, so 19.5 degrees is what we're looking for here. That's better. Okay, next up, find side A if A is 53.5 degrees and C is 15 meters. So again, here is our triangle. Side C is 15 meters. This is a right angle. Here is angle A, 53.5 degrees. And this is side A. So we've got this formula. We know that sine A equals A over C. So then the length of A is equal to sine of A, C times sine A. So here, that's going to be 15 times sine 53.5. Again, go to Desmos. And we get the length of A is 12 point, it's probably close enough to just 12 meters for our purposes. Find the hypotenuse of right triangle RST if R is 32 degrees and angle R is 32 degrees and side R is 25 feet. So here is our 32-degree angle and our 25-foot side. And now this here is going to be C, or the hypotenuse. So now we know that the sine of 32 degrees equals 25 over C, which means that C is 25 over the sine of 32 degrees. You can plug that into Desmos or any other calculator. I'm not going to bother showing you how to do that again right now. I'm just going to put in 25 divided by sine of 32 and get that this is about 47.2 feet. Next, solve triangle DEF, where F is the right angle, D is 32.5 degrees, and E is 24 inches. Okay, so here is what we know. Here is our right angle F. We'll call this D, that's 32.5 degrees. This is angle E, and this is side E, which is 24 inches. Okay, so we need to find the measure of angle E, the length of side D, and the length of side F. The easiest thing to do is figure out angle E because we know that the lengths of the sizes of the three angles add up to 180 degrees. So D plus E plus F equals 180. And we already know that D is 32.5 and F is 90. And if I add those two together, I get 122.5 plus E. So E is just 180 minus 122.5, which will give us 80, let's see. 57.5 degrees. Now that we've done that, we can figure out the lengths of D and F pretty easily. Since we know the measure of E and the measure of angle E, we can use our sine rule. Sorry. So F is going to be equal to 24 over sine 57.5 which is about 28.5 inches. And then to find D, D is equal to F times the sine of 32.5, or sine of D. So that's 28.5 times sine 32.5. Which gives us 15.4 inches. Oh, I made a mistake. I put in, let me double check that. We said 28.5 and I wrote 28.65. So it's actually 15.3, not 15.4. It doesn't tell us how many decimal places to use. I'm just using one decimal place. Find the included angle of a right triangle that has a hypotenuse of length 3.6 feet and adjacent side of length 1.99 feet. Okay, so here is our angle. We'll call that theta. Our hypotenuse is 3.6 feet. And our adjacent side is 1.9 feet. Well, we've got the adjacent and the hypotenuse, so we can use the cosine for this. We know that cosine theta equals opposite over hypotenuse. So in this case, that's going to be 1.9 over 3.6. So then theta is equal to cosine inverse 1.9 over 3.6. Plug that into a calculator. And that becomes 58.1 degrees. Next, we're asked to find the hypotenuse C of a right triangle that has an acute angle of 55 degrees and adjacent side of length 15 meters. So here is our 55-degree angle. The adjacent side is 15 meters. Here is our right angle. And here is C. So now we've got the cosine of 55 degrees is equal to 15 over C, so C equals 15 over cosine 55. Plug that into a calculator. And we get a length of 26.2 meters. Find angle A of a right triangle that has an opposite side of length 14 meters and an adjacent side of length 16 meters. So here, all we're given, here is angle A. All we're given is that this side has a length of 14 and this side has a length of 16. Well, the tangent of A is 14 over 16. Therefore, A is equal to the inverse tangent of 14 over 16. And we could simplify that to 7 over 8. I'm going to do that when I write it down, but you don't have to because it'll come out the same. That gives us an angle of size 41.2 degrees. Next up, given this triangle, find side C to 4 significant digits and angle A to the nearest tenth of a degree. We're given the size of sides these two sides, 6 and 9. That is respectively side A and side B. C, so we know that C squared equals A squared plus B squared. So that's 6 squared plus 9 squared is 36 plus 81, which is 117. Therefore, C is the square root of 117. Sorry. I was using my own calculator and it messed up. I should have stuck with Desmos. Take the square root and I've got 10.8167. To 4 significant digits. Then to find find a to the nearest tenth of a degree, it's best to use the numbers that we know exactly. And we know a and b exactly. So we can use the inverse tangent. A equals tan inverse of 6 over 9. Well, 6 is 3 times 2, 9 is 3 times 3, so this is tan inverse of 2/3. And that gives us 33.7 degrees. A jet takes off at a 30-degree angle. If the runway from takeoff is 875 feet long, find the altitude of the airplane as it flies over the runway. Okay, so we know the length of the runway. We want to know the height above this, which is we'll call that capital A, the altitude. Okay, so easiest thing to use here is the tangent. We know that tan of 30 is equal to A over 875. So A equals 875 tan 30. Which is 505.2 feet. A stretch of roadway drops 30 feet for every 300 feet of road. Find the angle of depression of the road. Okay, here is our angle of depression A, or angle of declination, angle of depression, they're the same thing. We want to find the value of A when we know that the opposite side is 30 feet and the hypotenuse is 300 feet. Well, that means that sine A is 30 over 300, which is the same as 1/10. So A is sine inverse of 0.1, easiest thing to enter. And that's going to be 5.7 degrees. Okay, this last problem is a little more complicated. We want to find the angle a rafter makes with a joint of a house, a joist of the house, if the rise is 12 feet and the span is 30 feet, and we also want to find the length of the rafter. So the rise is 12 feet, the span is 30 feet, but this is the midpoint. So we can say that this part right here is 15 feet. We've got the rise, we've got the run, which means we have the tangent. Tan theta is 12 over 15, which is the same as 4/5. So we take theta equals tan inverse of 4/5, which is the same as 0.8 if we want to use that. We get an angle of 38.7 degrees. We can also find the length of the rafter a couple of ways. We can use the Pythagorean theorem, or we can use the length of angle theta, or the size of angle theta and the rise or the run. I'm going to do it with the sine I know that we'll call this R, that sine 38.7 is equal to 12 over R. So R equals 12 divided by sine 38.7. And that's 19.2 feet. And we'll just double check that with the Pythagorean theorem. Square root of 12 squared plus 15 squared is 19.209. So yeah, that's a perfectly good, either way we get a good answer. All right, guys, that's it for this video, and this is the last video of the year. So good work, and get in touch if you have any questions. Bye.